Hello, everyone. This is Dr.SHIVA. Today, we're going to be having a discussion about fish consumption and skin cancer. So this is the agenda that we're going to go through today. We're going to cover the paper that came out about fish consumption and melanoma and skin cancer, but we're going to look at it from the context of the science and the truth. We'll come to this. In some ways, how the New York Times sort of tries to push a narrative, and they should know better because they claim they know better than everyone else. And then we're going to look at the health possibilities, what that involves and the mechanism. So we'll come back to that in a little more detail. And we're going to look at the clinical study that was done that shows a correlation between people who consume fish and melanoma. And the paper specifically says, quote, fish intake and the risk of melanoma in NIH, AARP diet, and health studies. But the way the New York Times presented this study, they did it in a clickbaiting way to essentially force, in my view, because they know better, they want to force a narrative that without educating the readers, that it's sort of a done deal, that the correlation established is done, and you don't really need to worry about the knowing the why. But our approach at VA Shiva, everything we do is to educate you on a systems approach. About a month ago, I shared all with you a study that we had done that went beyond correlation, but took a systems approach to understand causation. And this was from correlation to causation. We shared with you work that we did in an NIH-funded project with the City of Hope, where they had found, again, this correlation between people who drank green tea was highly correlated with when they got a transplant. Let's say they got a lung transplant, heart transplant, whatever it was, they had a much greater chance of the transplant not being rejected. That means green tea consumption. So if you got a transplant, you had a higher chance that your transplant would not be rejected if you were drinking green tea. Again, you understand this is a correlation. We were interested in finding out why. In order to do that, you need to take a systems approach. A systems approach cannot be done by just doing input-output, which is what modern science really works at. Systems science allows us to do that. And by the way, we published our research, which I'll share with you very briefly. You can go see the green tea video, but I just want to share with you the difference. We published in the Clinical Nutrition Journal, one of the leading journals for clinical nutrition. But in order to do this, we used CytoSolve, which is a systems approach to understanding this. And as many of you know, the systems approach that we do, so the study just came out by Lee et al., and it came out in the journal called Cancer Causes and Control. And here are the authors of the journal right here: Yufi Lee, Linda Lau, Rashmi Sinha, Tanshang Sheng, Terrence Vance, Brar Qureshi, and Yanyang Cho. So the title is Fish Intake and Risk of Melanoma in the NIH AARP, I think it's Retired People Diet and Health Study. What did this study do? Well, what the study did was, in the abstract of most of these papers, they will try to give sort of what they're going for. And it says, purpose prior epidemiological studies. When you see epidemiology, it's typically input-output. It's not going to a systems analysis. Let me be clear. An epidemiological study or an analysis is not a systems analysis. We at VA Shiva and all the work we do is to deepen your consciousness to understand the why. But regardless of that, sometimes it's good to understand if you do this here, what occurs here, because then you can understand what's occurring inside that black box. So this says prior epidemiological studies evaluating the association between fish intake and melanoma risk have been few and inconsistent. Few studies distinguish different types of fish intake with the risk of melanoma. So what they claim is that's what their study really did. So they looked at nearly 491,367 participants, and then they used statistics, and then we're going to go through this. But what they concluded was, it said we found that higher total fish intake, tuna intake, and non-fried fish intake. So let's look at the three groups. Total fish intake. So they looked at people over a 15-year period. It says during this period of all these people over a 15-year period, they had 5,034 malignant melanomas and 3,284 cases of melanoma in situ, which means they hadn't spread yet. So these were malignant. These are things that hadn't spread yet. And so again, just to be clear, it was 491,367 participants in this study. And if you looked at that number of participants over 15 years, they come up with an interesting number, 6,611,941 person years. So that's sort of the full scope over that period, they had 5,034 cases of malignant melanoma, which means melanoma that's spreading, is pretty bad, and 3,284 cases of melanoma in situ. And what they found was a higher total fish intake, tuna intake, and non-fried fish intake were positively associated with risk of both malignant melanoma and melanoma in situ. Again, melanoma in situ means it hasn't spread. Further studies are needed to investigate the potential biological mechanisms underlying these associations. So they actually point this out, but the New York Times really didn't point that out. The researchers here brought that out, and this is the why. So here we're looking at the details. The study population here again was 491,367 participants over 15 years, ages 50 to 71. You can see all different ethnicities: Black, white, Hispanic, Asian, Pacific Islander, American Indian, Alaska Native. And the fish intake was fried and non-fried, and it varied between 3.2 grams per day to 43 grams per day. So it's a pretty wide range. And so they had these different quintiles of people, quintiles 1 through quintile 5. These are different segments of people. So then what I also wanted to point out is they had quintiles by fried and non-fried. So this group was those quintiles separated by the fried group, people who did fried fish intake, and the non-fried fish intake. And what you notice, the correlation, by the way, if you see a p-value of 0.001, that means highly correlated with relative to reference. And you see here, the fried fish intake group is not correlated. The multivariate analysis, and here, both in malignant melanoma, here, and here, this is a reference, 0.36, 0.06. But here, if you notice in the non-fried fish group, it's 0.03 and 0.003 and 0.001. The lower that p-value number is, which means it's highly correlated. But the results of the study, CI, confidence interval 1, indicates strong correlation. So what that means is so all study groups Q1 to Q5 showed positive correlation between fish intake and cancer diagnosis, and correlation was observed for both sexes, all ages, and all ethnicities. Okay, so very high correlation, total fish intake in all these different groups. Again, in the malignant melanoma and melanoma in situ. So here's getting into a little bit of the details. So what they found was, this is what's fascinating, they found that if you looked at those group of people who had tuna, and so if you look at a can of like Star-Kissed tuna, that's about a 5-ounce can of tuna. So they found out those people who took about 0.3 grams, which is 0.01 ounces, which is, by the way, a tenth of a tablespoon. And if you compared that to those people who had just a tablespoon, by the way, this is over that 15-year period. Just to be clear, we're looking over a longitudinal study. So over that 15.5-year period, I want to make sure I'm being clear, over that 15-year period, if someone had about 1 tablespoon of tuna, which is what that 14.2 grams, it's a half an ounce. If you think about a can of tuna is about 5 ounces, and if you take 1 tablespoon and you have a tablespoon spread out over 15 years, which roughly comes to around 14.2 grams, and if that's a median average amount you consume, then you're going to have an increase of 20% higher risk of malignant melanoma and 17% higher risk of stage 0, which is melanoma in situ, which means it hasn't spread. So there's melanoma, it hasn't spread. A malignant melanoma, it's spread. So again, just to give you those numbers, this is tuna. So think about someone, I don't know how much is, let's say you have a tuna fish sandwich and you use a whole can, and that would be sort of 10 of those units and let's say you had 1 can every 10 days for 15 years, you have a 20% higher risk of getting malignant melanoma and 17% higher risk of stage 0 melanoma. So that's the first takeaway. The second thing that was interesting was, again, this is again a correlation, was when they compared the 0.3 group, which is about a tenth of a tablespoon, and they compared that to people who did 17.8 grams, which is a little more than a tablespoon of non-fried fish per day. This is non-fried fish. So this could be sushi. This could be canned mackerel. This is any fish, any kind of fish. If you were having about a little more than a tablespoon a day, in this case over 15 years, 18% higher risk of melanoma, pretty much close to that taily tuna, but a 25 higher risk of stage 0 melanoma. All right. And what's fascinating is the researchers did not identify significant associations between consumption of fried fish and risk of malignant melanoma or stage 0. So isn't that fascinating? So this gets down to the causation piece. So people were assuming non-fried fish or tuna had a 17 to upwards of 25% risk of the melanoma, which wasn't spreading, and melanoma, which was spreading. Okay. So that's one of the, but if you fried the stuff, there was really no risk. All right, so let's go to the next part here. This research that we just talked about was a correlation-based research. Input, output, input, output. When you understand causation, you can actually create products that work. You can identify why, and you can create healthy products. So what we did was we actually used CytoSolve, this causative approach, to actually discover a product where by the way, CytoSolve's been used for 16 years by many, many companies, but we looked at the mechanisms of pain and inflammation, and we were able to discover a set of ingredients, which actually, we're talking about negative things which could cause cancer, but there are materials that you can take that actually will do beneficial things. I wanted to let you know that we use the technology here. We've helped many, many companies over the last 16 years, a lot of smart, innovative companies, but we decided with all the mathematical models we've created, why don't we try to use this to compute the best product we could think of from the science out there for reducing pain and inflammation, pain and discomfort. And that resulted in us creating MV25 using CytoSolve. We're going to have more products that are going to be coming, but let me just show you what MV25 is about for those of you who haven't heard about it. But this is using CytoSolve in a beneficial way, not to just do research, but find combination therapies.
Hi, I'm Barbara Ann. My hands would cramp up so that I couldn't hold cards or knit or crochet, and they would go like that. And I'd have to use this when I played cards with my grandkids. And I started taking that MV25. After a bit, I was able to hold cards in my hand, very, very little cramping, hardly at all anymore. MV25.
Hi, my name is Sandy. I'm a Taekwondo instructor. I tore my ACL during Taekwondo. I had a lot of pain and limited mobility. I've been taking the MV25 for about 6 months now. After the first week, I noticed a big difference. After the second week, almost literally no pain.
My name is Jeremy, and I suffer from a lower back problem. Hurt my back at work years ago, and I can go to the chiropractor, do all kinds of different things, and nothing seems to help. And I decided to try MV25. I didn't notice a difference immediately, but within a few days, the pain went away, and it stayed away. I've continued to take it, and even when I do things that I shouldn't do, it seems to go away a lot quicker than it ever did before.
It's clean food certified. It's made in the US. If you go to vashiva.com, right on the shop, you'll click there, or you can go right to mv25.life, either way. And then from there, you can click on the bottle and you can order. If you buy 6 bottles, you get 6 bottles for free. Please take advantage of it because first of all, it's going to help you. It's going to help our movement, and it really supports the fact that we want to take science-based approaches to natural products. Now, in the research that we did with CytoSolve, again, this is an example of not a correlation study, but it was going from correlation to causation. So as I mentioned in this study, people have found consuming green tea lowered transplant rejection. Pretty cool. So what we did with CytoSolve, which was published in this paper, was we actually understood how that occurred. So notice it says bioactive compounds in green tea may improve transplant tolerance. A computational systems biology analysis. Notice what we're saying here. It's not an epidemiological analysis, but a systems biology analysis. So what we did here was we literally understood the composition of green tea, the caffeine, the minerals, the amino acids, the polyphenols. And by the way, I'm not going to go through this in detail for the interest of time, but there's an entire video I did on green tea and our research earlier. So please go check that out. But what we did here was we understood all the compounds in green tea, the molecules, and then we understood the molecular mechanisms, the actual causes. We went through all the research and we pieced together causation, how individual molecules react, and how the components of green tea, EGCG, which is one of them, or epicatechin, these are molecules in green tea, how they actually affect the causation, affecting other systems which promote transplant tolerance. And we identified those anti-inflammatory mechanisms and how it works, why it works. And then we did the same to find out how other compounds in green tea, EGCG, epicatechin, and gallic acid actually lower transplant rejection, essentially downregulate pro-inflammatory mechanisms. So this was very powerful that we were able to identify the actual compounds, identifying the mechanisms, and this is what I mean by the why. So we found out how green tea promotes transplant tolerance and it inhibits prevents transplant rejection through downregulating pro-inflammatory mechanisms and upregulating anti-inflammatory mechanisms. So I wanted to give you that as a data point to understand how you can use system science to understand causes. And so whenever you hear on the news, because if you don't have causation, you can be really bamboozled into a narrative. I did something here and over this happened. And we see that in every major topic. And this is why the world, the United States in particular, is split into left and right, pro and anti, because the news media and essentially academics who can be paid, because they're now practicing the oldest profession in the world, and you can think about what that is, you can essentially just use correlation to manipulate people. But if you go down to understand causation, which is a much harder thing to do, you'll understand, well, that may be true, maybe it's not true. And that's what's also true with this example here, with the example that we just went through. We're going to go through with the fish and the melanoma. So that's what I wanted to talk about. And one of the powerful things is when you really understand causation, and what we've done with CytoSolve is we've created a whole technology to understand causes. When you understand causation, you can really go solve some very powerful problems. And I'll come back to this because I want to share with you that using CytoSolve, for example, we actually understood the mechanisms of inflammation and pain in the body. And we went through all different natural compounds and we discovered a set of compounds that do that. And I'll come back and share that with you shortly. But what's happening in science is that you can easily have this sort of what I call attack on freedom, because you can have what I call the clickbaiting. And this is sort of the clickbaiting that the New York Times did. Can your diet really affect your skin cancer risk? Now, the New York Times really shouldn't do this, because if some other newspaper do it, they'd say, that's clickbaiting. But if the New York Times does it, they're very clever when they ask it as a risk. But the interesting thing is that there really goes to push a narrative in a very subtle way to assume the discussion is over. This longitudinal study has shown it. But the reality is we want to understand the causation. So just like the green tea example, if you want to really get to the heart of health, we need to know what are the potential mechanisms of action. You may want to write that down. In biology, we call that MOA, mechanisms of action. That is very, very different than correlation. Correlation is input-output, but understanding mechanisms of action is saying, I did this input, what were all the pathways that it went through to get this output? And that's a much deeper complexity. You have to understand all the connections, and that's called the mechanisms of action. So what were those mechanisms of action? What are the potential mechanisms of action here that fish intake causes cancer? Well, here's some ideas. There could be various things, and that's what we do, because if we're wanting to understand the why, we want to do that. So here are some of the potentials of the why could be, right? Maybe there's the mercury's ubiquitous now in the biosphere, including oceans. Is there an association between higher mercury levels and skin cancer? That's already been established. So there's been a number of papers written that shows that higher mercury levels and skin cancer are correlated. They don't know the mechanisms, but that's been established. So if you eat a lot of fish, is it the mercury? And the mercury consumption in the US is mostly from fish. And by the way, this was done in the United States. Hence, there's a potential link between fish intake and skin cancer. So again, what we're proposing here is a potential causation. We're proposing a causation here. So this is the why we're proposing. Another thing that we were thinking about is the processing of fish. How was the fish processed? Raw? Because what this research said, it was all non-fried stuff. So non-fried, the canned, the boiled, and the raw. It appears that these kinds of processing was a high correlation, just like tuna, to the skin cancer. All right. So is that, and what is the mechanisms of action, or what happens when you fry something and you don't fry something? So is it possible that you have fish with a lot of mercury, and maybe when you fry the hell out of it, it's doing something in an interesting way that's protecting the mercury, if in fact is a mercury, from affecting you? Or is it parasites? Is it sushi? So these are some very, very interesting questions. And that's why many years ago, research came out that said, if you eat eggs, you're going to get heart disease. And for 20, 30 years, people stopped eating eggs. And again, it was one of these correlation studies, when in fact, it turns out if you soft boil an egg, don't overcook the hell out of it, but soft boil it and leave the yolk intact, there's lecithin in there, some very good nutrients which help. You need a certain amount of good cholesterol, but actually helps break down certain of the bad cholesterol. So once you understand mechanisms, you can say, wait, whoa, what do you mean that everyone should stop eating eggs, or everyone should stop consuming fish? And a lot of people stopped eating eggs. And if you really think about it, we can do a whole series on this. There's a huge correlation between consuming 1 or 2 eggs and the reduction in stroke, the reduction in heart disease, the reduction in cholesterol, because mechanistically, there's constitutive materials that actually help that. So we have to be very careful when we just look at these correlation studies. That's really the point that I wanted to make here. Now, in summary, if you look at this, going back to the mercury piece here, now there could be potential contaminants. There's also someone put up there could be other things, PCBs, polychlorinated bifenols. There's the plastics, the dioxins, the arsenic. These things are also in fish, and they've also been correlated with cancer. So there could be these other things. So in summary, what we want to really take away is that this study found that fish consumption is positively correlated with skin cancer. Consumption of fishes like tuna and non-fried fish increase the risk of malignant and skin zero, which is malignant, and stage zero, that means this cancer hasn't spread, those kinds of cancer. On the other hand, consumption of fried fish was not positively correlated, and the study did not show any causation between fish consumption and skin cancer risk. That means they didn't show causation, they showed correlation. And the potential causes may include many things: mercury, PCBs, dioxin, arsenic, etc. So this is now a virgin area of research that people could explore. Have a good evening. Be well.